A warm good evening to all. Today we are going to see one of the most used ceramic, which is Xylon. In the previous videos we have seen two types of ceramics. One it is SiC, which is silicon carbide, and the another one is Al2O3, which is alumina. Okay, now we are going to see most important ceramic, which is known as Xylon. So here it is Si, Al and On, right? So this Si, Al and On means that it is silicon, aluminum, oxygen and nitrogen. So in this you can see there are four different four elements are added. Okay, so the Xylon have the complex chemistry and should be thought as a family of alloys with a wide range of properties. They are formed when silicon nitride, aluminum oxide and aluminum nitride are reacted together. Means that there are three different chemicals are added. The first one is Si3N4, which is silicon nitride. The next one is aluminum oxide, which is one of the ceramic which we have seen in the previously, and the next one is aluminum nitride, that is ALN. When we react these three elements together, three alloys together, we get Xylon, which is SiAlOn. Okay, this Xylon is particularly used in major of 5 applications. One is automotive applications. Okay, next one is in aerospace applications. Next one here it is used in the electric insulators around the wires. Okay, the next one is in the metal forming tools, as you look here, the metal forming tools. Okay, and seals and bearings, which you look here. Sorry, these two, seals and the bearings. So here this 5 applications makes this Xylon best suited is for these applications, which because the first one is low density and high strength, as like the other two which we have seen, which is aluminum and the SiC. You can see these two properties is seen there. Okay, so you can simply say that these three ceramics are common in one thing, which is it's of low density and high strength, so that these ceramics are used in replacement of metals of which have at par with metals. So because of it is used because of the properties as low density and high strength. The next one is it is in superior thermal shock resistance. So this particular application, particular property, superior thermal shock resistance, means that it is used in the metal forming tools. So the metal forming tools like forging or heat or hot working, you can see the metals are forged by using by using a hammer like thing or a dies which is of high temperature. Okay, so this superior thermal shock resistance makes them so that this property is well suited for the Xylon, which so that it is used in the metal forming tools. Okay, the next one, it is as moderate wear resistance, as this are used in the seals and bearings. Okay, this moderate wear resistance is much important when it is used like bearings in the fans or in the industrial application, blowers, etc. Okay, the next one is on fracture toughness. Okay, so you can see this fracture toughness helps in the industrial application area, and that it is the last before one is mechanical fatigue and creep resistance. Here the comes into the picture is that, see, these Xylons are used in the automotive application, aerospace applications, where this here the Xylons are employed in these applications where the high speed machines comes into the picture. So this ceramics should avoid the should have the resistance towards the fatigue and creep, which because these two failures where one occurs at the high speed machines and other occurs at the high temperature on imposing mechanical loading, high temperature and on imposing mechanical loading. So when you can see this high speed, you can see in automobiles, and on the high temperature you can see on the aerospace applications. So these mechanical fatigue and creep resistance helps us to helps the Xylon to be employed in the automotive and the aerospace applications. Next one is oxidation resistance. So this can be easily used in the metal forming tools, okay, in order to avoid the oxidations. So that's all for today. Thank you and have a great day.